This lesson 8-3 is about transformations of quadratic functions, basically transforming parabolas on a graph and being able to recognize the change in the equation. We're going to look at a different form of the equation today. We did transformations of linear equations. I don't know if you guys remember that, but that was back in first semester. So this time we're going to take a parabola, we're going to move it up, we're going to move it down, we're going to move it left, and we're going to move it right. We're also going to reflect it. And so I know there's at least one type of transformation you don't learn in Algebra 1. Maybe there's two that you will learn in either geometry or Algebra 2. And we're also going to be stretching and compressing these. So I think that transformations of parabolas are a lot easier than transformations of linear equations. So hopefully this will make sense to you guys today. So some of these words may come back to you, but when you're shifting a parent quadratic function up, down, left, or right on a coordinate grid, that's called a translation. So okay. Ooh, I did not write that very nicely. When you're reflecting a parent quadratic function over the x or the y axis, that is a reflection. When a parent function is coming closer to the y-axis, further from the x-axis, that is a stretch. And when the parabola is closer to the x-axis and further from the y-axis, that is called a compression. Okay, so I'm going to read through this. Right now, we're going to focus on translations, vertical translations. This would be shifting a parabola up or down on a coordinate grid. So vertical translation, up or down. So you're going to take the parent function. Remember, the parent function is like y equals x for linear or y equals x squared for a quadratic. Remember, and then like y equals x cubed would be like a S-shaped, but y equals x squared will always form a parabola. And when we say a parent function, it's your original function of the parabola, meaning the vertex is at 0, 0. Okay. So you're going to take the parent function, y equals x squared, and you're going to add or subtract a value to that. It's represented by the letter k. So here are your equations here. Y equals x squared plus k, meaning that you're going to move the parabola up, vertically up, or y equals x squared minus k, meaning that you're going to move the parabola vertically down. So I just went over all that. So other variables may be used other than k, such as d. So if like you're researching this online, sometimes it says d, sometimes it says k. For what we're doing today, it's going to be k. Now here is I'm going to give you the full equation. Okay, it's going to look a little crazy. So f of x, all that means is y, okay, equals a times x minus h squared plus k. So right now we're just focusing on the k. If the k is positive, you're moving it up. If the k is negative, you're moving it down. All right. A represents a compression or a stretch. Oh, H represents a shift either left or right. Yeah, so here we go. I can't explain that to you right now. If there was a negative in front of it, that represents a reflection. The A represents a compression or stretch. The H represents a horizontal translation, so moving it left or right. And then K represents the vertical translation, moving it up or down. And I think that's going to be on another page of our notes in a minute. So if you look at example one, f of x is replaced by f of x plus k, where k equals -3. Determine the effects on the graph of a parent function, which is f of x equals x squared, when it is translated to f of x equals x squared minus 3. A lot of words. Basically, all this is saying is when you take a parabola, y equals x squared, and you add, or I'm sorry, subtract 3 from that, what is happening? Well, a negative means down, 3 means down 3 units. So we are translating, translation. I'm going to put translation. Can you, oh, you can't see it, sorry. Translation, 3 units down. Okay, that's what that is. So we're just describing the actual equation. We're describing the graph based on a given equation. So now what happens if we have x squared plus 5? Well, translating it up five units up. Yeah. Okay. So let's look at this graph right here. So we're going to write a table. Wait, are we going to do? No, we're not going to write a table. So what we're going to do is the parent function is the blue one. Okay. So the blue line is going to be f of x equals x squared. Okay, so that's your, can somebody tell me how we know it's the parent function? Yeah, the vertex is at 0, 0. All right, so now the red line at 1 is going to be f of x equals x squared plus 1. The green one is f of x equals x squared minus 1. So go ahead and do the purple and the orange. Okay, so that's kind of how you recognize it from a graph and how you recognize it from an equation. All right, let's go ahead and go to page 2. Oh, yeah, I'm sorry. Okay. Moving to the back. Now we're going to do horizontal translations. So a horizontal translation would be shifting a parabola right or left. Now, remember, we're going to write this again. And we're going to write it right here. We're going to rewrite the full formula. So f of x equals a times x minus h squared plus k. And right now, we're going to focus on the h. Ugh. Okay. Where when you're subtracting h, it's going to move to the right. And when you're adding h, it's going to move to the left. Now, a lot of times we look at this differently. We look at it as if it's negative, it's going to go to the left because that's where our negative numbers are. And when it's positive, we're going to go to the right because that's where our positive numbers are. Do you remember when we were doing point slope equation where you had x minus x1 equals m times y minus y1, and how when you plugged in an ordered pair, it changed the sign a little bit. That's kind of how this is right here. So if you're adding, then it's going to go to the left. So it's like the opposite. If you're subtracting, it's going to go to the right. So here we're taking a parent function and we're shifting it 7 units positive 7 units, which is going to be translation 2 units left. Okay. I'm sorry, 7. Okay. And then here we have a negative 2. So this is going to be a translation. Yep. Okay. So now we're going to look at it from a graph. Our parent function is the black line. So f of x equals x squared. Okay. And the red line, we're just going to write it how it is up in the examples. So for the red line, it's going to be f of x equals x. What's the red line? Yeah, it's going to be plus 2. And the blue line minus 2. Okay. Oh, and that is going to be squared. Okay. All right. So 7 and 8. Go ahead and do 7 and 8 on your own. And you do have to write translation on this because I don't know if you're referring to 8 like a reflection or although it wouldn't, or I just lost my words, a compression or a stretch. Go ahead and check that. And then we're going to move on to page 3. Yes.
If you like you let the units, how would that be like a stretch or compression?
I'm just saying like if you write, I guess if you said 8 units left, that would be fine. But what I want you to use the vocabulary. So I want you to do the translation, say translation. All right, moving on to page 3. Now we're looking at a reflection. The reflection is represented by the A in the equation. So we're going to write the equation again down here. F of x equals negative A times x minus h squared plus k. And we're focusing on that negative. If there's a negative, then it's some form of a reflection. Okay. So determine the effects on the graph of the parent function. We have a negative right here in front of the x squared. So this is just going to be a reflection over the x-axis, okay? Okay, now in the next one, we have a negative, but we also have a plus 2. There's no parentheses here, so we're not talking about a horizontal translation. So we know the negative represents a reflection over the x-axis. And the positive 2 represents a translation. Are we going up, down? Are we going up or to the left? Huh? Up 2 units up. All right. If it were left, then that means there would be parentheses in there, and the 2 would be in the parenthesis. Okay. Okay. Let's look at example 11. We have two graphs here. So because one parabola is opening up, one is opening down, and they're equidistant from the x-axis, this is a reflection over the x-axis. Okay. Okay. All right. What about this second one? Tommy wants to say. Okay.
So first, since it's you have one opening up and one opening down, it would be a reflect over the x-axis.
Okay.
And then after that, you see that it's moved down. It would be you would translate 1 unit down.
Mm-hmm. Yep. And translate 1 unit down. Actually, on this one, it's 2. Do you see why it's 2? Because this is 10 up here. Or I'm writing on my other, it's 10. So it's going by 2s, but I can see at first I saw it and said 1. So yeah, translation 2 units down. Uh-huh.
For the rest of the parent function includes the function.
Yeah. Okay. Good. All right, let's go to page 4. We're halfway done. So a vertical stretch and a vertical compression. Okay. A vertical stretch is closer to the y-axis. Okay. You take the parent function and multiply the entire function of x squared by a number greater than 1. Okay. So for example, if you had a regular parent function and you like y equals x squared and it then became y equals 2x squared, that means you multiplied it by a factor greater than 1. And so this would be a stretch. And that means it's glowing. I'm trying to talk too fast. It's stretching closer to the y-axis and getting further from the x-axis. Okay. All right. A vertical compression is getting closer to the x-axis. And this means that you're going to multiply the entire function by a number less than 1. Okay, so we have 2 up here and we have a half right here. This will cause the parabola to shift closer to the x and further from the y. Okay, so it's further from the y right here. And this just means that, okay, so let's go ahead and write the function again up here. We're going to write f of x equals a times x minus h squared plus k. And when we're talking about a stretch or a compression, we're talking about the a. So if your a is greater than 1, you're going to have a stretch. If your a is between 0 and 1, you're going to have a compression. Okay. So example 12, determine the effects on the graph of the parent function when it's converted to f equals 4x and then 1/4 x. So this would be a vertical stretch by a factor of 4. Oh, sorry. Um, As long as you say, actually, no, you don't have to say vertical or horizontal. You could say stretch or compression. Well, these are both verticals. We're not doing horizontals here. But if you do stretch by a factor of 4 and compression by a factor of 1/4, that's fine. And then when you're saying shifting, as long as you say left or right or up and down, you don't have to put vertical or horizontal. So this is a vertical compression. Got a factor of 1/4. Okay. Okay. Let's go down to the graphs. Okay, ignore the red right here. We're just looking at the green and the blue. So the green, not the green, the blue is your parent function. And I know that because the equation is in blue up at the top. And then this one right here represents how it was transformed. So it's A is greater than 1. So that means that it is a stretch. So stretch by a factor of 4. And then the next one, again, the blue one tells us that that is the parent function. So the red one, oh, we messed up on this, is a stretch by a factor of 3. Gentlemen, please. Okay. All right, let's move on to page 5. This is going quickly. All right, so here is the entire equation explained. All right, you have a stretch and a compression, which is represented by A. The H is the shift left or right, and the K is either shifted up or down. So we are going to graph some equations here. So the parent function, I'm gonna f of x equals x squared has been transformed to f of x equals x minus 7 squared. So first, we're going to write it in words, and then we are going to complete the transformation. So what are we doing? Shifting it 7 units to the right. So you can say shift or translation, it doesn't matter. So the first thing that we're going to do is we're going to write out the parent function. So when we do the parent function, I'm just going to come back up to the top. Where you have f of x equals x squared. This is going to be x, and this is going to be f of x. F of x is just y, okay? And we know that our vertex is going to be 0, 0. So we're going to graph this so that we have 2 points on either side of 0, 0. So we're going to do -2, -1, 0, 1, and 2. Now, you do not have to do this every time. I just want to show you what the ordered pairs look like when you graph a parent function. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay. So now we're going to graph that as our parent function. Are there any questions about that? What? Okay, okay. So we're taking the parent function f of x equals x squared, and we're going to graph it. But before we graph it, I want to create a table of values to show you what those values look like. So we're just taking f of x equals x squared, and we're trying to find what x is and what y is. Does that make sense?
Yeah. That's just what's with the points.
Right.
Okay.
Okay. No, that's okay. That's okay. And sometimes I need to stop so we can process it. You need to stop, or you need
That will always be the for the parent function.
for the parent function of x squared. Yeah. Sometimes your parent function will be something different. The parent function might start out as a different equation, but for f of x equals x squared, this is how it will be. So I'm going to go ahead and graph this one. So we have -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4. Now, this is... Okay, now I'm going to use a different color. Oh, I have all my colors over here. And I am going to now graph the translated function. So we know that it just shifted 7 units to the right. So every point can be shifted 7 units right. Now you could create another table of values if you wanted to and plug in the x and solve it that way. But if you know what the shift, how to shift it without doing all that work, you can do that. So I'm going to just take every point and I'm going to shift it 7 units to the right. No, you're not. Okay. Questions about that? All right. Let's go ahead and move to example 19. Okay. And let's read that. It says the parent function has been transformed to -1/3 x squared. Describe each transformation that was performed on the parent function in the graph. So what is the first thing that we notice? It's, yeah, negative and 1/3. Now you have to treat the negative and the 1/3 separately. The negative tells us that it's a reflection over the x-axis. And what does the 1/3 tell us? Yeah, compression by a factor of 1/3. Now, when I do my compressions and stretches, I always create a table. And so we're going to have to do that. So the first thing we're going to do is we are going to draw our parent function, and we can use the same table of values that we did before. So go ahead and draw that parent function again. Now we're going to reflect over the x-axis. And all that means is that your, right, so all of your y's are opposite. So your x values stay the same, but your y values become negative. Okay. So my next one is going to be my reflection. So I'll have it at 0, 0, -1, 1, -2, 4, -4, and then 1, -1, and 2, -4. Does that make sense when you're reflecting? Or you could just do equidistance from the x-axis too. Oops, I did that wrong. Equals. Yeah, we're going to compress it now. Yeah, you have to do, I mean, you could do it both. You can do them both at the same time. Sure, you could do that. I'm going to draw the next one and we'll do a table of values. So y equals -1/3 x squared. Let's do that. And so we're going to have our x and we're going to have our y. Now remember, because this is a fraction, we want to use factors of 3. Yeah, we're going to use, yeah, -6, -3, 0, 3, and 6. Okay. So we're going to plug those in. So -6 squared is 36, and 1/3 of 36 is, yep, -12. 1/3 of 9 is -3. And we're going to go off the graph just a little bit. Okay, so now let's graph that. So yes, you don't have to do both of these on your homework. Okay, so let's go ahead and graph these. We're going to go -6 all the way down to about here, -12, -3. Do I need to stop for just a second? Okay, then 0 is up here. And then 3, -3, and 6, -12. And then we're going to draw that or sketch the parabola. So then this one is f of x equals -1/3 x squared. There we go. I really didn't need to do that middle one. Questions? Okay, last page. We're almost there. So these are just 2 more that are multiple functions. I want you to, on this one right here, the negative symbol should be on the outside. It should not be on the inside. So just know that that should be on the outside. What I would like for you to do on these 2 is to go ahead and work with a partner on completing these, and then we will come back and check them. All right. So when I turn the screen back on, you will see the answers. Okay. Okay. So on example 20, this right here should be your final one. Okay. So I reflected it first. I shifted it left second, and then I shifted it up third. Okay. So, and then you should have gotten a reflection over the x-axis, translated 3 units left and 6 units up. Now, if you don't do it in this order, that's fine. You should still end up with the same final parabola. So this right here was your parent function in blue, and then in green, that should have been your final parabola. So if you don't do all of them, that's fine, as long as you have the parent and the final. Okay. All right, so hold on just a second. All right, now I want everybody to do example 21. Okay, so with example 21, you should have written reflection over the x, stretch by a factor of 3, shift 4 units up, and shift 2 units. I'm sorry, shift 4 units left and 2 units up. Now with this one, because it has a stretch, the best thing that you could do to get your final parabola is just to create a table of values to see what that final parabola would be. So in this case, I have x and f of x. And normally I would choose like -3, -2, 1, 0, 1, and 2, 0, 1, 2, and 3. Now, because I've already done this, I know that because this was the one I did last year, and I reflected, then I shifted 4 units left, then I shifted 2 units up, and then I did a stretch. Huh?
It's reflection.
Reflection. So I'm going to reflect. I'll just do each. So if I reflect, no. Oh, you're right. Hold on just a second. Okay, so what I have done when you're shifting all four, or when you're making all 4 transformations, you do the reflection, the shift left or right, and the shift up or down. And then by doing that, you can create a table of values that will tell you what your stretch or compression should look like. And instead of doing a whole bunch of guessing and checking on which numbers to plug into the equation, it's very simple. Your vertex is going to be the same vertex of your transformed parabola. So, or the -4, the axis of symmetry, basically. So when I'm creating a table of values, I know that my vertex is going to be negative, let's see, -4, 2. So I'm going to have -4, 2 in the middle here. Now I'm going to go -5, -6, and then -3, -2. And I get my 5 pairs, and that will help me to figure out what the stretch is going to look like. All right, I'm going to stop right there because I see a little bit of crinkled faces. So are there any questions about that? Or can I maybe try to explain it again? Explain it again. Okay, so here, once you figure out all the transformations that need to be made, you could do all of them except for the stretch or compression. Because once you get to the last transformation that you did, for example, mine, I reflected first. I did this one first. Then I shifted 4 units left second. And then I shifted 2 units up third. Okay. When I did my last transformation before my stretch, this is what I got. Now I know when I stretch, my vertex is going to be the same as this last transformation. It's going to be -4, 2. So that when I create my table of values, -4, 2 will go in the middle. And then I'll choose 2 units below it and 2 units above it to create it without trying to guess and check which numbers I should use. So because when I stretch this, it's still going to have the same vertex, but it's going to be closer to, it's going to be skinnier.
Take the vertex and have that as your determined middle, and then you put two below, and work out the like f(x) equals -3
Mhm.
x plus 4. And then those points are where you will place your dots.
Your dots, and that will be your final transformation. What do you do to find what? The x values? Oh, you plug this into the equation over here and you solve. So for example, -6 plus 4 is a -2. -2 squared is 4. 4 times -3 is -12. -12 plus 2 is -10. Now, I did that all in my head, but you can use a calculator. All right, so you're just plugging these x values into the x of this equation and then using order of operations to figure out your y.
If you like -5 is 4 squared, would you only square which variable?
Just the one. So you solve. So like if you plug a -5 in here, okay, I'm gonna get rid of everything. -5 plus 4 is a -1. Then you square it, you get +1. And then you multiply it by -3. You get -3 plus 2, which is a -1. Yeah. Is class almost over? Oh no, we still have 8 minutes. Okay, so these are the final answers. Now I'm going to do my final. Hold on, guys. Okay, so I'm going to go ahead and graph these. -6, this is going to look very messy. 10, -10, -5, -1, -4, 2, -3, -1, and -2, -10. So then it's sharing points from some of my other ones. Yeah. So then that was stretched because it's skinnier. Okay, and so that would be your final. So I'm going to put this one as 4 stretch. Okay. All right, that concludes lesson 8-3, transformations of quadratic functions.